So we just found the Maclaurin series for sine of x. What if we want to find the Maclaurin series for x sine of x? We could go through all the steps that we just went through, but something is even easier than that is if we multiply x times our expansion for sine of x. So that gives us the sum from 0 to infinity. When we bring this x in, notice I can bring the x in and out because x is independent of n here. This is just an x to the first power. So I can bring that in, multiply it with the other x, and I've got negative 1 to the n, x to the 2n plus 2 over 2n plus 1 factorial. And I'm done with it. So this was Maclaurin x. All right, so next let's do a Taylor expansion for, let's do sine x again, but now at x equals, I don't know, let's go with pi over 4. So in order to do this, we need our nth derivatives evaluated at pi over 4. Let's do a quick unit circle. Here's pi over 4, so our point is square root of 2 over 2. So all of our sines of pi over 4 will be square root of 2 over 2, and all of our cosines will be square root of 2 over 2 as well. This might end up to be too easy, but we'll see. So f of x equals sine of x. F prime of x equals cosine. Second derivative is negative sine. Third derivative is negative cosine. Fourth derivative is sine, and now we are repeating the pattern. Okay, so we need to start evaluating these. So what do we get? Square root of 2 over 2. Square root of 2 over 2. Negative square root of 2 over 2. Negative square root of 2 over 2. And then start repeating. So we see this pattern. Notice that it's not quite alternating. You do 2 of 1, 2 positives, then 2 negatives, 2 positives, then 2 negatives. Okay, so let's start writing out our terms. So our first term is going to be the square root of 2 over 2, and then we have plus the square root of 2 over 2 times x minus pi over 4 to the first divided by our 1 factorial plus negative square root of 2 over 2 x minus pi over 4 to the second. There's our 2 factorial. It's a little too big. Negative square root of 2 over 2 x minus pi over 4 to the third. So this is our third derivative information right there. 3 factorial. And then so on. In this problem, since they're not quite alternating, what we could do is we could split up the series into two different summations. We can kind of group those even terms together as one summation, and then the odd terms together as a second summation. Or if we want, we could try to put it all together. But I think it's easier to see with to make it alternating by writing them as two summations. So our first sum is going to go the square root of 2 over 2 times negative 1 to the n times x minus pi over 4 to the n. Now notice we've got to have our n's as even numbers. So 2 to the n divided by, and again, so here's 0 factorial, 2 factorial, 4 factorial, and so on, so 2n factorial. Does this work starting at 0? Starting at 0, we have square root of 2 over 2. Okay. Starting at 0, we have a positive. Okay, that works as well. Negative 1 to the 0 is positive. Then we have no x terms for that very first term. So when I have it to the 0, that works. And then 0 factorial in the denominator. That works. For our next term, that's the squared term, does this work out? When n is 1, I've got square root of 2 over 2. I've got a negative. I've got this stuff to the second power. I've got 2 times 1 factorial, 2 factorial. It works. So this is going to take care of all of the even powers. And now I need something to take care of all of the odd powers. So I'm still going to have a square root of 2 over 2. I'm still going to have a negative 1 to the n. I'm still going to have an x minus pi over 4 to the n. And I'm still going to have some kind of n factorial. But that's not right. We know that's not right because the powers are not going to work out. So the first thing that I want is I want this to the first power here. So looks like I'm going to need a plus 1 on my exponent and in my denominator. We know we're going to need more than that. But so when n is 0, it starts off to the first power here and 1 factorial down there. So that's good. Also, we need to start with an even. If I use just n here, does that start off with an even? Yes. Okay. Then we know these powers have to be evens. Sorry, odds. So I need to do 2n plus 1. Now, do my powers go 1, 3, 5, 7, 9? Yes. But my denominator needs to also go 1, 3, 5, 7, 9. So now I have 2n plus 1 in the denominator with the factorial. It's going to go 1, 3, 5, 7, 9. My signs start positive, then negative, and that works out. And our powers go 1, 3, 5, 7, 9. So there you have it. We've got our Taylor expansion for sine of x centered at pi over 4. It's a little bit more complicated, but don't let it stop you.